Right. Let's okay. Waiting a little while longer. Okay. Okay, that's enough of music for today, lads. It's enough. Okay, so I used to always say like hello, or welcome. I won't say that this time. Okay, all right. Or I actually said that. Anyway, okay, I don't know why the colors bugged out. Let me just look at it's okay now, doesn't it? Or avoid maybe. Yeah, it looks okay. Okay, great. So I'm looking at PRs. So we have the zip and compression deflate. And the way I do this is I usually would check out the whole thing. And now I get an IDE error. So let's see here. I think this might be the one. Breadcrumbs provider. I'll definitely look at that one. I'll copy paste that bug. I think that's an old one. Very old one. Okay, so and then after I checked it out, I will do a diff with master. So that I can see where things were different. So branch and tag, let's do it with master. Okay, no difference. Okay, maybe I did something. Yeah, just diffed a single directory. So okay, we are diffing here. So we get a bunch of changes actually, but that's mostly because things have changed in the master branch since this happened. And to do like fix that, I'm just going to merge. I'm going to merge the master branch into this origin master. So that way we can better see what's different. Okay, so we have a bunch of tests. Okay, I usually don't look at the tests very carefully. Oh, yeah, that's what changes. Why didn't I get the other one? So go to side-by-side viewer, right? Oh, it's a new one, right? So that's why. We have some changes to, okay, file libc, right? It's getting these like uteam buff, which is this time t thing. I'm not sure that we'll need like the libc time t thing. We can probably just use libt, right? So so time t like this, because nothing else should look like that, I think. But let's just make sure that it kind of works by just compiling this dummy here, right? Main. Oh, there's the error again. Yeah, that works. Maybe there's something with, you know, Windows or something that has different. Okay, so we have these two functions. They are quite different, so it makes sense that they are like this. And then we have like create the native set modified time. So let's use a StackMem to do this, which is good because don't want that to necessarily allocate memory. Okay, so yeah, so you update it and then you get new ones, and if it fails, then you get the general error here. You could maybe get something else, but that's the way it works. The normal libc one has this set modified time function, and it will use that. Right. I think this is similar as like everything else. Then we have this set modified time, which is maybe unfortunate that it has a dependency on libc here. But for now, I'm just going to ignore that, actually. It shouldn't be like that, but I'll ignore it. So instead, here seems to be something, some tweak. Let's look at the actual, like the meat of it. So we have deflate. Let me just open it in a non colored one. So we have this API, like decompress, blah, blah, blah. And then we have compress stream, and we have these allocators. And now I'm going to say this is nothing like, I'm just going to change some things, right? So in this step decompress, it takes the allocator like this, and that is not standard for the standard library as it is. So instead, we always do it explicitly, and we always make it the first parameter like this. And this one as well, like as soon as you have an allocator, you always like go for put it in the beginning. I guess it's a bit ziggish in that regard, but well, we always do it like this. So I'm going to pull it in here, right? And then we have it explicitly instead. So not looking at just now, just looking at that particular part, and then we'll look at the zip as well. I think it's going to be like similar, that it shouldn't be okay. So why we import core? This looked like automatically imported, to be honest, because like this is never needed like that. So okay, a compression, okay, like this. So I think maybe these were automatically imported or something. Right, so we have this information, right? We have do state to time. Okay, so there's some way to retrieve the time, and then we get a time, not a time t, right? Which is better, right? And then we'll have, okay, so we have a zip method, which is u short le, and here we go. We have some modes, right? But here we don't want to do it like this, right? We do want that particular, we want to present the allocator as the first thing we do. So like this again. That means we can maybe change the ordering here. It's just nicer. And then we open it. If it is v plus, otherwise we take v. So change the mode, right? Then we have the allocator, we init things, right? Now, usually I would actually go for a, setting those explicitly like this. And then, file as this. Oh, that's an init. Okay, then I can do it like that. Okay, so we do get these. Use an error, then you're going to close. Have you allocated memory? So here, right, we're already done, so we don't need to think about any memory that we want to return. Okay, and then we seek to the end, right? And oh, why do we do this? Can't we get the file size automatically? Okay, I'll fix that later. Just let me just run the test, because probably we will end up, we're gonna end up having to fix these because they are we have mem here, right? We have mem here. Allocator first, right? Oh, okay. Maybe I did something wrong. That's like that, I think. Then we have this one, and we use mem like this. I think this automatically converts, so there is no need to do that. Here we compress, so we use mem. Here we already used that one. Here's something else. We use mem. Decompressed. Yeah, I was supposed to fail. Compress again, we need mem, and we don't need to cast it. And here we need mem. Mem. This is because I am messing with the API. What are your opinions on Zig? Do you dislike it? It's not the language I would pick. I picked between when Jai was like when Jonathan Blow was doing all his streams on Jai, and no one could use Jai because that was like way before beta, and everyone was like wanted to play with some new CLI. Zig popped up, right? And I got interested in programming languages, program language design, and compilers. And I decided I wanted to contribute to one. So I was looking at like, should I do it for Zig or something else? And I was like looking around, and what I found was, I found other languages. I found C2, and I liked C2 much more than Zig. I think it was much nicer and more readable, easier to approach, and so on. And C3 is basically a continuation of C2. So yeah, I don't like it as much as like C and C2 and Odin and Jai. I don't like it so much. Because I think it has like a lot of weird design decisions that doesn't make sense to me. It feels very, very verbose to me. Like I'm back in Java again, something like that, right? And I don't know. I think that there are experiments in Zig that didn't, at least to me, didn't pan out well. If they failed, but I mean, I think also the things like the costs and stuff like that. I don't understand why you went to add that amount of friction. So so yeah, I basically I'm been unable to appreciate it. And for me, I can write C, and C is perfectly fine. And I think like people who are attracted to Zig tend to be like, yeah, Zig is C is bad. So since I don't think C is bad, just that it could be improved, then I guess I'm not in the in the audience for Zig. Zig is more like, here we are going to revolutionize programming. We are having this amazing language that's going like to make everything, do everything new ways, and we are going to show them. Like Andrew says, he feels like I'll show them, and I just don't. I don't find the problems that Zig tries to solve being problems for me, and they create problems that I didn't have with C. So that makes it very hard for me to appreciate Zig. And of course, I'm working on this, which is competitor to Zig, but I feel like I'm more of continuing, this the C2 language, even though it's been restarted recently, fairly recently. But I worry that you will just go down again and not like it won't actually be completed. There's a much less work being done on C2 than there is on C on C3. Just if you just look at what I do, there is more activity. Right, does that answer the question? Hopefully it does. So Avian did that. Are you happy with that answer? A lot of places to fix here. Huh. Very simple, but a lot of places. Okay, could have done this differently, but I also wanted to The reason I do this manual is because I want to see this code to also understand it. So because I'm doing this manually, I'm seeing more and more of these uses so that I can understand what it is. Maybe get to the point where it actually compiles again. Ooh, let's run these tests. They seem to pass, right? And then we have the benchmarks, right? Bench the standard library. I think this is it. Okay, here we go. So I don't know about this play cache thing, which seems to be broken. And it's like still broken or something. I don't know. Like, I don't know what's up with that. More Blake stuff. And more Blake stuff. Okay, no more comments from Avian. Maybe you left. I don't know. Yeah. That was like a hit and run, right? Kind of went there and asked and then left. Benchmarks deflate. You cannot cast a what? Why can't you cast? The string is inline. Oh, allocator, yeah. I was like, yeah. Did I do something wrong? Did I break the compiler? Nope. Mem goes first. And it might not seem like, why do we do this? It's because it's actually easier to have it at the beginning. It just makes it super obvious and there's just one single place. Once you have like varargs and stuff like that, you don't want that to be the last element. And we went away from having that implicit heap allocation because then we had to have naming that told you that it was returning something. So okay, now the tests are doing this, but yeah, it's working at least. Okay, so now to the next phase here, right? We let me just kill the benchmarks because I think the benchmarks are not sensitive to actually when it's closed. The output is closed. So let's go in here. And so we have the deflate again and the zip. I was kind of disappointed. I mean, I'm disappointed Avian left when I was, musing about what I think about the about Zig. Right, we have a stream between we have a flint later, and we have this buffer that you can optionally add. And then it has the buffer. Let's see, is it dynamic? It's a read. Yeah, so because it's possible that to use it in the stream. Okay, let's go look at code. That's a lot of these. And you have a reader inside of it, which is the streamlit reader. Sync, right? The reader, yes. And then we start in the block and ensure the fixed build. Okay, so fixed build global. Okay, there's okay, so this is something a little dangerous. I think this is like right. It doesn't really matter if they overwrite it, right? Unless there's like the build has a state or something. So lit Huffman. Right. Huffman right build. Yeah, there is actually a problem here. Okay, so we need to do like we want to have threads here. Import, not core man. Let's use this. Let's see where we have it. Like we had. Sure. There you go. So we're gonna have a, like a static. What's the name of it? It's once flag, right? And this once flag, once flag, the flag. Run once, and then we. How do we use that? I just used it today, and now I forgot about it. So once flag. Right, here we go. Call once, yes. And then we run once, and then we have void like lambda here. Do this, and we don't need to have this. That's already fixed. So there we go. And we have run once on this call. Something like this. I just heard something from the other room. Maybe a cat did something bad. Right, let's see that this works. No, presumably this worked, right? We could just break this, right? So if assert false, assert 1 equals like this, right? So that one should fail when we get in there, right? Okay, this will always be forward. Yeah, int x equals 3. Okay, and now x equals 1. So we can put an abort in there as well. We should get a failing test. There you go. Right. So fail, and it actually stopped there. So okay, now we got all this. Right. So it's running. Right? Okay, so this is much better. Ensure fix build. Right. Sure. Is it just running once? Like that's the only place for it. In that case, we don't need to place it here, I think. Sure. Right, it's because it just wants to do something once. And this is just going to be more efficient here. I just put it in here. Okay, so then we read is it done, stuff is done, and position is read, position return 0. Otherwise we do, okay, math mean, do we need that one? And why do we do this widening? Looks unnecessary. Buffer length, why do we make that u long? Why do we use min here? Sure, we can use the faster min, that's true. Okay, they want it. Okay, but this should be fine too. Like if I compile this, that be fine. No need to, yeah. This is correct though. This one, this one is, you don't need to cast it, but you need to cast this one, the other one, because it's this u long start idx. What's the size of that? Right, idx. What's that? It's a suicide. Why do this though? Like, it's so small, right? It's already a u long, isn't it? So why widen it? Read, okay, read pause. Read pause. Why is this one? It's a u long, right? It's a 64-bit. Okay, so then we take like this small thing of it. Like, why do we widen it to? Do we use it somewhere else? It's here, yes, but you can always widen it. So shouldn't that be u long? Right? And then just get this, and then this is like should be fine, right? And to copy, we just need a u long. There, we don't need to widen it. No need for those costs. And then the length here also doesn't need to be like more than a u long. I think so. Do we get any costing errors here? I don't think so, no. So there's no need for those costs. The buffer length, yeah, maybe, because it's like the total out, right? It could be bigger, right? But this part, like it's never going to be that big. Oops. Right. So this just copies. Now let's move this read pause. And here we go. Like the read pause is going to copy is a u long, right? And length is a u long. So you don't need that cost. And since that read pause is a u long, we should have a u. Just to make it short, make it more clear. Okay, if we get something, then we are done, right? So we can do it like this. Let's use some features. It's greater than 0, right? That should work too. Just to check here. Anyone else wants to ask me about my opinions about programming languages? I can do that while doing this. Let me just see that if I remove this thing here, it actually breaks. Right, I just think this is probably why didn't it break? Now I get very unsure of myself. I guess there's some place where that should be. What? I also tend to not use this equals 0, so I almost always do like this. create a new okay. So wait, is this why isn't this a byte writer? Let's see here. So okay, let me see what it does. So we malloc out cap number of bytes, right? I have to look at what it does. So okay, we have something. Let me start from okay. We have things in this temp bit. We have a temp bit buffer, right? And then we have an out cap, which is twice the size, and we put it at least 1024 bytes, 1 kilobyte. We then allocate memory for that, and we defer release of that memory. It's a bit unnecessary to do this compression with the memory, I think. But okay, so what we do then? So if we see that we can't, if the out length plus if we could do a push of 8K, if that would exceed things, then we do something like we are trying to efficiently realloc. And then we copy to that. Oh, and the target is this, right? And then we read to those using inflator read. Okay. Let's just say that I just want to make sure that this is being tested. So what happens if I don't do, if I like do like I don't know, like here we're copying that again just to get it even smaller, right? Those are unnecessary copies actually. And there is no need to use the main allocator inside, where you can use just a temp allocator. So this seems a little wasteful, to be honest. So like I would just use tmem here, right? And we're just going to run this in a pool. And then we don't need to free it, right? And then we allocate this memory. Malloc mod cap. We can do something else later, but just for now. And then if we are like this, we have theory alloc, right? trealloc, and it's something like that. So trealloc, what's the name? We use realloc array. Okay, trealloc. Maybe there's a trealloc array. Trealloc. No. So we're just going to grab the memory there, which is in out, right? And we are going to give it like the one we want next cap. There's no need to use like also here, I think. Yeah, so we are just having that. So we just realloc that with the next cap. No need to do realloc array. And then at the end, we can do the copy. So something like that. Hello. Concatenator. Okay, next cap. So let's see if this works. Because I think it's perfectly normal to just use the temp allocator. It worked, but is this tested even? So what happens if I just, you know, or true? You know, here we go. Okay, so that fails. That's good. No. Okay, so we actually have a byte reader here, right? So we actually have a byte reader for a mem stream, which takes that information, but why don't we use a byte writer here? Okay, let's say you have a byte writer. And then there's, I don't know, remember what it looked like. Okay, so byte writer, it does take an allocator. So we have a T in it even for that one. And we also have, it's with a buffer, and we can, I don't know if we can ensure a capacity. Yes, we can do that. So like there's no init here. Tmem. Okay, so we know that we want a certain amount of memory. You can do that. Okay, so let's do it. We go for byte writer and then to writer T in it, right? And then we want to ensure capacity. That's out cap. I think that was correct. I don't want to do too much here. Maybe I'm stupid to ensure capacity, right? It's not. It's just going to be like next part. Oh yeah, I'll try. Right, it's going to be. Let's see if this works. So we are ensuring this capacity, right? And now instead of, we don't need to do this, right? We don't need to do this either. We're just going to like do inflator. What's the name of it? So there's a way for streams to kind of stream to one to the other. Streams. So here you go, write to outstream. And then there's this copy through buffer, right? So you're basically copying through a buffer here, you see. So we can just do IO I think it's called IO, right? So let's see, even if it's in stream, yeah. So IO copy to. So we are going to go from this in stream to this destination stream. That would be like inflator IO copy to, and we have our inflator, and we have our writer, right? Writer even. There is going to be like some things here. It's going to be like copy to. There is going to be something that might happen when we do this, right? Copy to might fail in some way. So it's going to say like how much memory, how big that resulting thing was. But we don't care about that because it's going to track that inside of it. So like, okay, so we can have like outline. So if it's 0, then we just do that. Otherwise, we are going to take like this. We have this in stream byte writer, sorry, and we have an array of view of that, so we can just make a copy from that. So and let's see here. So we can get yeah, maybe the array view of that. So we're going to allocate as much memory. Now this one is fine. And we just take this writer array view. Oh, sorry, result. And then we have the array writer array view. And this should be copying that. So I don't know. Maybe this works. It didn't work. Okay. It's returns a void. What could be wrong in that case? Maybe you couldn't allocate more into that buffer. That's possible. So out length would shadow a previous. Okay, we have it. This one. Right. And then we have copy to writer. Okay, I just need to pass it by this. It would be funny if this worked. No, it failed. Okay, why did I do wrong? Oh, okay. Boom. Like decompressed data doesn't match original. Oh, let's see here. So we have this deflate basic, right? Let's just run this, right? Debug stuff. Put it in here. Make it a function. Void main. Right. But it looked almost okay. Right. So we are getting this decompressed thing, right? It doesn't match the original. So okay, let's print what it is. Print string decompressed, right? What you're doing for you? I wrote. Oh, okay. Like I'm looking at your PR. Did you change that? Because I'm actually changing things in your PR. Mano. Do you have something else that you want to change? Because I think I grabbed everything, all the recent stuff. Maybe you did something else. Okay, so didn't match. Okay, it was empty afterwards. So I am playing around with your deflate here. What is that? Okay. So this is actually nothing I should do anything about. I don't know. So like look at this decompressed. It can be like you can should be able to use the byte writer, but since this is not working, I think that's very interesting. Why is this not running at all? It's as if like let's do a quick check that it's actually getting there. No. There's an error. Oh, I put it there for those tests. Why didn't anyone tell me? Okay, so now it works. So you can do this like this, right? So this is the entire. So now works. I don't know if this like how this will. Okay, can you blah blah blah. What can't be implicitly total out? Oh, that makes sense, but it also doesn't make any sense to use this. Right. So, okay, I know, I understand now why you do that. So, but if it actually, that is pretty bad. So, like, if like if you start rapping, that would be bad. So this is a classic problem. What do we do? We have function for this math overflow. No. Overflow add. Right. So it's going to be like it should. So what I want to do is like okay, if length is greater than usize max, then we return what we corrupt the data. And then we have to look at, okay, then if it does have some overflow thing, right? There's an overflow somewhere. Overflow. It's gonna say like math overflow or something. Yeah. Find it here. Overflow, yes. So it's a math overflow, I think. Well, yeah, there we go. So in this particular case, it will be like a math overflow, or maybe it's corrupted data. Maybe it's corrupted data. Okay, corrupted data. If length, so total out equals total out add or overflow add. Overflow add. Yes. So we get this. Oop. Whoa. I've got a lot of them. Okay, so here we go. Overflow add. Overflow add length. Now we know it's we can safely cast it to length. And if there is error, no, we just say corrupted data. Okay. And then it will still be wrong, right? Because okay, we need to import. Yeah, but there is a method add overflow add technically. No, not add. Overflow add. Okay, overflow add. Right. Okay, I forgot to rethrow it, of course. So maybe there's something else here. We are doing the copy and well, at least like now we know that we're not overflowing in 32 bits. Right? Okay, so Manu, do you see this? Can I push my stuff, the changes I've done, and you have a look at that? Let me know. Okay, then I don't really dare to do more changes to this, but like this is definitely shorter than the other version. Okay, just rebase my changes over that. Good. Then maybe I could do some more things here. So, like if you decompress a stream, right? Here's we have the output is pretty big. Okay, we decompress it. We have create an inflator, right? And then we allocate the array. But don't we do like in the end we just output here, so we don't need like the allocator at all. We should just use the pool for this, like the temp pool for this. I don't think this is a place where you would implement it differently. So the inflator couldn't that be on the stack anyway? Oh, it's pretty darn big. Okay, I don't know. I'm sorry. It's pretty darn big. Okay, so like tnew like this, and then we, you know, have this, and then we can just do tnew okay, here we go. Here's something. Cannot in this case too, right? So again, we need to look at that. Okay, we can look at that later. So in this case, we can just do like this, right? And this should be fine. And we don't need to delete those at all. We do suddenly we have this out buffer, which we do allocate on stack. So I don't understand why we use that. Oh, okay. So again, I think we could probably just do like IO copy to, and then we have like inflator. We take that one and we copy to the output. Right. And then we can just do like this. I think. So this will break some of the things, I think, because the compressed stream would take an allocator. Oh, genius. Right. So I'm mostly not like working on the actual functionality, but just the API. And we should document this as well. So if we go here, locking and the temp allocator. And this one is also using the temp allocator. Okay, so we get a resulting thing, but let's see what it looks like. So we have a bit writer, we allocate, do the allocator, and then eventually we do a finish, and that one creates that memory. This one though. So, whoa, I'm not going to look at this one. Maybe this one will be updated or something. This is, we are in deflate, right? So I'm looking for more of that API. So zip the compression here. Let's look at that one. If there is something that we can reduce, like simplify the, like if you create an archive, yes, you might need an allocator to allocate some stuff for that, yes. But why do we have file by? I don't know. I'd have to look at that in more detail. Okay, this is pretty long, so I'm just going to look at the API where we do the extract and things like that. So here is something, okay, again, this API will need to change. And okay, I have someone here. Right, some paper from it's okay. So here we go. We do use the allocator, create some data. Right. And we create that deflate. And eventually that data is used somewhere. Okay. Okay, add directory. Read close. Let's look at the allocator. So that was the one I changed, right? So no, not recover, right? So let's fix those as well. It should be like this. So it should be like with the first thing, and no default. It's just the way, the reason is that I'm trying to kind of emulate aspect-oriented programming feeling, where you kind of set the aspect, the like in this particular function, we are using something in this way, right? And so that the first thing is like just saying what the environment is, sort of, right? And now we get like this read file all, which will need this mem. We'll have to look at the benchmarks then. And we have so many of those, right? So here we go. I hope this is putting. Yeah, okay. That's... Okay, we got the one. Here we go. Here we go. Here we go. Another one. At least there are a lot of tests for this one. That's very, very nice. Very, very nice. Okay. Still pausing all the tests. Let's look at the benchmarks. So just see that the benchmarks are compelling. That's all. Yeah, they were not using any of that stuff there. So let's see if I can find some like equals mem, right? And then at the end, so that's something like this. And the other one in zip here. Let's see if we have like equals mem. There we go. So the recoveries, that one has to change as well. So it should go to this, but I don't know if like, it's producing, yeah, it's producing a zip archive which will use this allocator, right? There's no other one. So let's see the benchmarks. They're still running in the background. Okay, let's quit the old one. Now the new one is running, taking a lot of CPU, I think. Let's gonna close them elsewhere here. So good. Benchmark run. Quit that. Okay, and then we have the test again. See if there is something there. Probably. There we go. Yes, these two. So we have the old mem, and then we can like consider whether a zip archive would need to allocate memory or not. If it's possible to do it without allocating memory, I don't know. I don't know what the benchmarks will be for this change. Nem, okay. I'm on a typo streak here. Also nem. Nem. How surprised people will be if I like had added aliases like nem and so on, which did just random allocations. Everyone would be rather surprised of their behavior, their program. Okay, I'm just going to tiny. I'm going to put like allocator first. Some changes to the plate to use copy to Okay, there we go. So another one to ban here. All right. Okay. Then I will commit this and push it. And then I guess I can't do much more about this. It's also containing the merges. So sadly, I can't do anything more about that one. It's going to be super exciting when we have it. Right. I'm really looking forward to that. So right now, let's see. I'm just going to look elsewhere and see if we have something else that is actually passing the tests. And speaking of passing the tests, there's this whole problem with the dev branch. So if anyone, there's sound over here now. So if anyone has time right now, I want to try to debug that with me. That would be super helpful. That's if you have a Windows machine and you're able to compile the dev branch and then see where the heck it is crashing. I don't know. This like it doesn't crash on Linux, not on Mac. So it doesn't crash if I target Windows. So it's just a crash for anything. Like the compiler just crashes on Windows. That's the only place where it crashes. Slightly annoying. So just say something in the chat if you want to give me some. Want to try it out. Right. What else? Let's go and see if we have some other thing that might be. There's this interesting thing. So let's view this one. CoinMarket's distributions in. Okay, yeah, so these are no air versions of these. It's like no lib, sorry, no libc version of these, and the gamma function as well. And then we have like distributions. So okay, let's see. We have distributions and we have distributions factorial, and then we have the additions to math, which is these gamma functions, right? So, and then we have some tests for this, and in the release notes, everything's added. Okay, so let's check out that one. If we can just add that, that would be awesome. Okay, so while Mani is looking for his maybe to start his VM, I'm just going to look at this. So again, I'll do as before. I'll just diff this with master. So compare with let's see, master. So we get a lot of diffs here. And this is a completely new one. So there's just this master thing in master. And what I mostly look for is actually just that it is still, tabs, because otherwise that's like kind of painful. Okay, so then we're going to go to distribution. So I'm going to open that one, distributions. Right, so we have some constants here, tolerance. Okay, that's the test. That was the wrong one. So distributions, there we go. So the mean given a distribution. Okay, so we have like two about what's this, an interface. Okay, so it's in an interface. Oh, and this is kind of OO, right? So you have something and you have a distribution and you do discrete things, and there's a uniform distribution and you can define new distributions. So it will just give you different things depending on where you are, where you put in for something. So This can sometimes be very useful. Here, okay, yeah, next table runs, that's correct. And there's a normal distribution, right? So we get, we have some sigma math pi, yeah. Right. Yes. So the normal distribution here, we get a random normal distributed one. And then we have an exponential distribution, right? This is for, I think, like for compare here, to have a t distribution instead. So it's okay. Yeah, that's fine. And let's see here. So we get this random chi squared. Chi squared. Clicking through these. It's a lot of code. Okay, random. Poisson distribution. So provides a lot of distribution. Let's look at this private part. So there's a struct here. Okay. Private. Right. Here's something binomial coefficient. I don't know if that should be in here. Like if it's in here, then it probably should be you know, this is sorry, but I get this looks fine, right? Except for this looks a bit cramped, right? So let's just keep it now I'm just going to be obnoxiously rigorous here with this. So we are doing like this. So let's go through that. Everything else looked okay. So suddenly the spaces disappeared. They were eaten by Pac-Man or something. So I understand why you want to compress it, but it's not very nice to read afterwards. Like I understand that you do this because yeah, I mean it's a read, you write only kind of thing. Let's keep it consistent. Right. Okay. No, that looks okay. This one is again that. Oh, okay. Not covered. Okay, this is interesting. All right. I don't understand though why this is. Some of this might not be. Something that should be private. I don't know. God, that was a lot of. What? That one jumped. Oh, and then we go and do. I think this looks like picked from some C sources because it tends to look like this. Especially maths. I remember when I was a kid, John, I always put them really together like that. And I thought this was much easier to read. But that was so long time ago. Nitpicking. Sorry about this. Right. Just want to keep it consistent. Can't have half the code base having space and then suddenly for some reason there are no spaces, and then people like, what's the rule for when you shouldn't have spaces? And then you go like, I don't know, there are no rules. There are no rules. That's not great. Okay, here's that. Yeah, okay. Then I'm just going to look at how is this used, right? So, because I just saw the math ones, I didn't see like this stuff in distributions. Where is that? There's the incomplete beta. There's use, yeah. Okay, so Newton Raphson's used here. Okay, that makes sense. Right. Those are all private. We don't. Do we have anything on the release notes? Yes. No. Standard library add discrete and continuous distributions to math distributions. Yeah, I'm just going to have these changes. And then I think like seems I don't have the VM available. We need a few hours. Okay. Oh, that's fine. That's fine. Maybe someone else will show up too. Might be able to help out. So I'm just going to grab. I think like I like having math methods, and they are so awesome when you have them. So I'll just test this, right? Make sure that it passes the tests. But if they do, I will just accept them. Just the part where you get like a random number from a given distribution. That is good for like super good. Okay, so let's approve this one. We're gonna do a squash and merge here, which you're not seeing because it's like elsewhere, but it's accepted. Thank you. How do you comment there? So we still have a bunch of pull requests. So we do have this test for comments that's not passing. So there are a lot of these tests that are not passing. We do have the struct equals. I'm not sure. That's the main reason why I haven't done anything with that is that I'm not sure we should have that. I'm still giving that some thought. But that gives me, actually, there are so many pull requests and almost all of them are not passing. There's the async sub-process for POSIX system. I don't really have time to try it out, and perhaps someone who has actually used a sub-process for anything else than just a test. They should try it out, make sure that it works properly. So that would be like this thing. I would really like some help for people to kind of look at this and see if it's good. So let me try to paste this. No, pasting doesn't work. Oh, okay, now it does. Right, this one. Otherwise, I think I'm like looking at this, right? Fixing this one had problems. I couldn't compile. Not this one isn't. This one isn't passing. This one is passing, but might not be needed. This one I have like want some tests for. This one is one that I'm wondering if we should really have, and there's this JSON marshalling library, and that's AI written. And there's another one which is not AI written, and yeah, so like there's this one too, which like these are drafts. All these are drafts, which is I can't really act on them. So let me see on Discord, see if someone has a question or something they want to raise, right? Okay. So issues, no, everyone's seeing that they are fixed. Oh, maybe I can just fix something. Okay, so let's see here. So there are issues, right? So there is an issue where this is search. So we are going to hunt for a bug, right? Let's go to a master, if I can manage that. And see if like I almost always end up making fixes, and it's not in master. Okay. And then we have this test code to kind of see that it was broken, right? I got some food here, so I'm just going to eat a little. Let's run this and see what it breaks. Okay, it breaks fairly early. We get the type, and it shouldn't be a void, right? Let's see. We have emit the member address and the member of a test. Okay, so test. Hang on, I'll be back. So give me like 5 minutes or so. Right, I'm back. So we're gonna meet this access thing, right? So let's see here. Why does it looks completely normal. Completely normal. So the value here at this point, maybe someone is opening yeah, the door looking in. So the value is at this point a void. Why is it a void? That doesn't make sense. Now, in order to debug this better, we want to jump into and see like the whole thing, how it gets there. So we're going to turn off the standard library. And, oops. Well, go to this point, right? Okay. Here we go. Up here. So, oops, at this point. Stop. So the parent is wait, okay, so the parent type is test. Okay, great, that's good. The value, though, is empty. As if something bad happened. Okay, let's go here. Here we go. Here we go. Yes, that's okay. So right now we do have a B value which has a value. Oh no, it doesn't have anything, right? So we're going into, let's see here, it's the deref. No. So we're just going to emit the BE value. So it's a expression, it's a binary expression, right? Maybe we just do something bad with the binary assign. Here we go, assign, right? So, okay. And now the BE value is going to be like the result of that assign expression. So most likely here we're doing something bad. Right. I think that might be easier. So we go to the catch. There's no optional. There's no catch. And it's a constellation initialized. No, it's an index list. No, it's a call. Right? So we emit that. And there's no ref expression. So we continue. We'll go after store. Now the value here. What? The expression didn't have a result. It should be returning a test. What happens if it's not packed? Like, if still fails, right? So there's nothing there. Okay. We get to this point. Emit the binary. So the problem is not in the assign, it seems, it's in the call. But the call looks super innocent. It doesn't look like it should be a problem at all. So we have to jump further down into this. So we get to the actual right, we go here. So we're gonna meet the call expression. It's a built-in no. Grab the arguments, la la la. Get here. It's going to, I guess it's going to return something by reference, but so func type. So we have a type for the function, la la la. We are going in here. We don't have any arguments. So there's nothing happening there. The save mode, okay. We do the contracts, but that doesn't do anything. Okay, and dynamic dispatch, then we'll do the call invocation. So again, we kind of get here. And there's not the row variadic. So by default, the result value is this empty thing. Okay, so then we have is the ret normal. Okay, so it's a normal return. Some alignment stuff. Then, so it's an S return. Is there a target? So there's a target because it's a method. No. No, there isn't. It's just a normal function. What is target in here? Okay, that's the value. That we are assigning to, okay? So target's an address, which is a type struct, okay? So we already have this, and we're going to do an sret return. Maybe it's so basically result value should be same as target. Actually target like this. And then it should work. Is that correct? It doesn't work. I expected it to break, but I didn't expect it to break like that. When you get back from there, this result value, what? Okay, one more time. Like the result value here now is an address. Apparently we are breaking that afterwards. Like we're not doing a rewrite. Yes. And we do, finally we do the raw call. And the result values are already okay. And if it's indirect, can I get to this point, right? And now, let's see, it's still fine. I can just break here. Oh, wait, it's like, I don't remember how I expected this to work, but what happens here is that, okay, so it says, oh, you have a SRET return, you know, then you must mean that you shouldn't, we should clear it though. It's only used there, right? If we just change this, where does it break? So it breaks in one or two places. Okay, if it's an error value or SRET. Okay, maybe it's okay. Maybe we shouldn't do this, right? Because we already know that we want to, you know, we already have that. So when we're doing a call and we like already have this, like at this point we have a synthetic return parameter or something. No? What do we have then? Like we go here. Okay. So we are here. We're just about to do like this raw thing, right? This call. We have our result value, which is the one that we're going to send back, right? So and we're giving, like we have this SRET return there, which is true because we are providing, where do I set that? Oh, we're too high up. So here we go. So we are giving this target here that we made up. So we have a target that will hold this call expression. And let's see here. So we're going to emit this call expression, and in the normal case, So we have a ref expression here. Okay, let's see. Because we end up with something as if we have this ref. So the ref is, yeah, that's the address that I want to assign to. And since we have a ref expression, do we have a ref expression? No, we don't have a ref expression. If we okay, I don't remember what the ref expression. Let's see here. So in this case, we are a left-hand side is something. So our ref expression is null, but our reference is this. Okay, that means we should use, like, if we have a ref expression, then we should have null. So here we don't have ref, so we get the ref back, right? Okay. So now ref contains this result. Right. But then we're returning value. So we have this ref. Why do we do that? So we do end up with, like, we go in here, right? We get out of it, come to this place. Yeah, let's continue. Okay, so essentially we get here. Yeah, go up again. Next place there. Now the ref should be updated. So here is the information, should be stored in there. So the next thing is, like, if the value type is not void, but what sets the value? So okay, like, we set it to ref, but I like, it's if, you know, if there's, what we're looking at is basically, okay, if there's nothing, right? There's an error, but we're storing, hang on, we're storing the value to ref. So since there is no value, we're not storing that. Okay, that makes sense. So if it's, you know, if it's 0, this should be like this, I think. So if it's void, then we should copy. Then we should set, like, ref value equals ref. Otherwise we store ref in else LVM store, like this. I think that's the missing thing here. I was like messing with it to much deeper level, and it should be there. It should be up here. Okay, now it works. So that was a little weird, but hopefully, like that was not testing anything, so this could just break everything. Yes, let's see. Let's see the tests. We should have like assignment. Here we go. We have some tests here. So there's like assign from call to struct C3. Oh no, so it should be a C3T. Grab that one. We need some target for this. So let's say target is this, the module is test. Then we expect test LL. No, yes, do that. Okay, so I can stop these tests now, and then we run this. We're gonna hit this particular thing, and well, that's it. So, is there any questions, by the way, so far? We I should assign myself to that particular thing, by the way. So it's a rarely used, I guess. Like it does work as long as the struct is not larger than 16 bytes, though. Yeah, because then it's not under indirect, so that makes sense. So I was looking at the description. Yeah. Did anything happen to the issues while I was like the pull requests? If there's a pull request that's working, then would be happy to look at that again. It doesn't look like it. Now I have someone questioning me, I think, here. 1 second. All right, I guess I have to take a break here. This is looking like just that particular thing failed, which means that this fix was correct. So basically, if nothing else fails, then it's a good fix. So I'll just leave this running, and then it will be done. Like the big thing is the change in const that I haven't been able to push out because of it happened to be in dev. I might just make that separate from the other refactoring if we can't find the bug there. It's so annoying that it just appears just on Windows. So it's not even like it's compiling. I added some tracing and turns out it's compiling, and then towards the end of the compilation it just crashes. Like before it can print any information that's useful, it just crashes. So anything like any way we can track down why it happens or where it happens, would be awesome. I tested with sanitizers. There doesn't seem to be any UV that could cause it. I tried the usual suspect, namely designated initializers. That was not the case either. So it's just who knows. But anyway, thank you for watching. I'll just shut down the stream here and have a good evening. Goodbye.